You guys can see that then?
Yep.
Yep.
Hi, I'm Curie.
I'm Emma.
I'm Matt, and we are Team 14 Saving Solar. For our project, we partnered with PSC&G's Solar for All team to help manage the high penetration of distributed energy resources, mainly solar, on the power grid. PSC&G, New Jersey's largest utility company, is working towards New Jersey's state goal of 100% clean energy by 2050. Solar alone cannot do this due to mismatches between solar generation and power grid consumption. This is shown on the plot where characteristic solar generation is in blue and characteristic energy consumption is in red. Energy storage systems can be used to redistribute the times at which solar-generated electricity is consumed, essentially matching the generation curve to the consumption curve, otherwise known as load balancing. As residential solar systems become increasingly popular, our program seeks to recommend to residents, the power consumer, the right amount of energy stored to balance their personal load curve to overall balance the grid's load curve. This means recommending the correct number of battery storage units as determined by the consumer's energy use. Initially, we had an alternate design of performing this task at the grid level, using PSE&G's utility-sized energy storage systems to perform load balancing. Implementation of our program on PSE&G's grid could introduce a cybersecurity risk, and therefore we chose not to follow this path. Although the primary stakeholder of the project is PSE&G, we wanted to incentivize the end consumer financially by optimizing their savings. We considered using a flat rate model for pricing energy, but ended up with a peak pricing model. In a peak pricing model, energy costs more during periods of high demand compared to consumers being charged a flat hourly rate at all times. Peak pricing is slowly becoming more popular in areas with high use of residential solar. This is because it encourages people to use their stored energy at peak pricing times, thus encouraging load shifting. To optimize consumer savings, our program incorporates a behavior model where consumers would use or sell their own solar-generated energy during peak pricing hours.
Our tool is built to specifications created by user feedback. The user feedback was obtained through end-user surveys, which were facilitated by PSE&G. Through these surveys, we found that users would be willing to spend between 15 and 30 minutes using our tool. Users were largely motivated by their financial benefits, which led to our decision to include finances as part of the outputs. Our tool is a pioneer in the field of energy storage calculators, therefore there are no existing tools to test against. In lieu of this type of testing, we decided the robustness of our tool would be analyzed by ensuring that a 5 to 10% change in the input does not drastically change output. Per the end user feedback, our objective became to make a user-friendly tool which recommends the correct amount of energy storage to consumers for their individual energy needs while optimizing their financial commitment.
Okay, thanks.
The advantage of our tool is the vast amount of PSE&G data at our disposal, leading to higher accuracy when compared with using theoretical data. To avoid overwhelming the user by asking for technical information, our tool takes in user-friendly inputs that people outside of technical fields could easily find. This includes their roof size, home address, 12 months of their electric bills, and asks them to choose a curve describing their electric consumption. The program then outputs the optimized storage option along with 2 others. With each option, their yearly savings and years until return on investment are also displayed. These outputs relate to the problem statement through satisfying our primary stakeholder, PSE&G, by recommending the correct amount of energy storage to benefit the power grid. It also benefits the end user through optimizing their financial commitment in easy-to-understand terms. As mentioned, our tool is unique because of the vast amount of data we receive from PSE&G. We obtain general load curves, electric rates, and service fees. Additionally, PSE&G worked with us throughout the project to provide technical guidance on a bi-weekly basis. We also use PV Watts, an industry standard tool, as a source for solar generation and weather data. We assumed customers would purchase the industry standard battery, the Tesla Powerwall 2. We also assumed that solar panels would operate at 15% efficiency, a widely accepted estimate used by solar system designers. Finally, at PSE&G's request, we assumed that customers would use a peak pricing behavioral model. We chose to implement our program in MATLAB in order to use the guide tool, which allowed us to connect a user interface to the back end of our project.
This is a high-level description of our system diagram. A more in-depth analysis will be provided in the video. Roof size and address allow our tool to calculate the amount of electricity the customer will generate hourly over the course of a year. Monthly electric bills and a qualitative description of energy use allows our tool to calculate electric consumption, or load, hourly for an entire year. The data on generation and load are then put into a program which simulates the use of a solar and storage system. This simulation also uses a peak pricing behavioral model and outputs the amount of solar and storage system size, yearly savings, and years until return on investment. When designing our tool, the most important aspect was to adhere to professional standards. Since our project is largely data-based, PSE&G did not want to expose legally protected individual customer data to cybersecurity risk over the internet. Therefore, PSE&G's circuit data was used rather than individual electric users' data.
Before the video, we just want to take a moment to thank PSE&G. Our presentation would be incomplete without acknowledging their tremendous help and guidance. We are very grateful to have their wisdom and professional experience, and thank them for taking the time to work with us. And that concludes the slideshow portion of our presentation.